All right, we're going over the review we did in class. So remember, this is over our properties, prime factorization, exponents, order of operations with exponents and integers. So let's go ahead and get started. I want to find the prime factorization of 180. If you remember, prime factorization is when we're dividing or when we're breaking down a number into its prime factors, what it's made out of in terms of prime numbers. Remember, prime numbers are building blocks. The common prime numbers that I said I want us to remember are 2, 3, 5, 7, and 11. Honestly, if you can remember 2, 3, 5, and 7, you're golden, okay? So I taught you there's different strategies you can use. A lot of you are hardcore tree diagram. Some of you, I've kind of introduced the ladder. I'm going to use the upside down ladder to break it down. So it's 180. I'm only going to be dividing by prime numbers. And remember, we can take this any way we want. So I'm going to go ahead and do 180 divided by 2. And we would get 90. I'm going to keep going by 2. You could also do 3. You could do 5. But I'm going to keep going by 2. And you get 45. I'm going to keep going by 5 now. And I'm going to get 9. Don't make the mistake of stopping at 9, because remember, 9 is not prime. It can be divided by 9, 3, and 1. So it's not just itself and 9 or and 1. So that means I can keep dividing it by 3. 9 divided by 3 is 3. So I'm done. How we write it is I'm going to look, okay, 2 to the power of 2 times, there's 3 2's. There's 2 3's, my bad, times 5. So again, it's listed from least to greatest and in its exponential form. All right, we're going to go ahead and evaluate the expression. Make sure I'm with the right one. Yeah, okay. We're going to evaluate the expression. So I have 4 times -5 plus -12 divided by 4. We are going to be following order of operations, which is GEMDAS. Okay, do I have groupings? Well, yeah, I do actually have groupings. So I'm going to look at the grouping, and it's -12 divided by 4. If we need to, this is when we go off and do Dorito Man. Negative, positive, it's a -3 plus, rewriting it. Okay, our next step is to check if we have exponents. I don't see any. It's multiplication or division from left to right, but I do see multiplication. 4 times -5, positive, negative. So it's a -20 plus -3. And they're the same sign, so I'm going to go ahead and add, so -23. All right, same thing. We're still following order of operations. I don't see any grouping. Remember, a group is 1 or more numbers. I do see exponents, so I'm going to go ahead and do the exponents. Remember, this is -3 times -3 times -3. Remember, hopefully you remember the trick I showed you that when your exponent is an odd number, we're going to get a negative answer, because a -3 times a -3 is a positive 9 times -3 is -27. So 7 plus a -27. Remember, I said those integer rules do not go away, so we have to remember these are different signs. So I subtract, so 27 minus 7 is 20. And since 27 is bigger, it's a -20. All right. Number 3. There are 246 graders at Malillo. 3/5 of the 6th graders prefer TikTok, 1/4 of the 6th graders prefer Instagram, and 1/8 of the 6th graders prefer Snapchat. The rest prefer Facebook. How many 6th graders prefer Facebook? So I know that 240 is my total. That's what I'm starting off with. So we're going to break it down from there. I want to find 3/5 of 240. So 240 times 3/5. I'm going to do 240 times 3, which is 720. We're going to divide 720 by 5, which is 144. So that means 144 students prefer TikTok. Now we're going to find a fourth of that. Finding a fourth of 240 is just doing 240 divided by 4. So 240 divided by 4 would be 60. So that means 60 prefer Instagram. And then an eighth, again, it's just the same thing as dividing by 8. So 240 divided by 8 would be 30. 30 prefer Snapchat. So now what we're going to do to find out how many prefer Facebook is first we got to see how many of the 240 prefer TikTok, Instagram, and Snapchat. So we're going to add it up. So 144 plus 60. 4 plus 0 is 4. 4 plus 6 is 10. Carry the 1. That's 2. Then I'm going to add the 30. So 4, 3, 2. So now I'm going to go ahead and I'm going to take this total because this is how many prefer all of those other ones. And I'm going to subtract that from 240. Hopefully we see that we would get that only 6 students prefer Facebook, which kind of makes sense, right? So 6 students prefer Facebook over the other platforms. All right. What is the value of the expression below? Ooh, kind of a hint here. Remember, expression means that there's no equal sign. Remember, it's like an incomplete sentence. But just a recall so we don't forget that. So let's go ahead. I'm going to write out my GEMDAS. And I'm going to look, is there grouping? Yes, there is. I need to do 4 plus 9, which is 13. So I'm rewriting everything. Times 6 squared. Okay, I'm going to look to see if there are exponents. Well, yep, there are exponents, so I'm going to do that next. Remember, this is not 12. It's 6 times 6. So 6 times 6 is 36. I'm rewriting that. I'm done with my exponents, so now I'm going to look and see what I see next. So what I see from left to right is multiplication and division. So I'm going to do 7 times 13, and that is 91. Minus 5, 36. I'm not done with multiplication or division. What I see is this 5 times 36. So 5 times 36. Let's go ahead and do that off to the side. 6 times 5 is 30, carry the 3. 5 times 3 is 15, but I add 3, so that's 180. So 91 minus 180. Remember, this is like when I would say, we know we're going to get a negative answer because I'm taking away from a smaller number. So we need to do 91 minus 180. So I know it's a negative 89. All right, next one is I want to match the property to the correct expression or equation, right? Remember, it could be both. Associative, if we remember, associative is it's associating different numbers together. This is the one that has the parentheses. So I'm going to look, and this one, it looks like it's 3 plus 2 plus p. It doesn't look like it's associating different numbers together. So I'm going to keep looking. Oh, I see parentheses in this third one. Let me see. Is it associating different numbers together? Well, not really, because on the second expression, it took away the parentheses, so it can't be that one. Let's look at the fourth one. Well, the first one did 3 times 5 in the parentheses, and then it looks like it associated different numbers together. So, associative goes with this one right here. Okay, commutative. Remember, commutative, it changes the order. So I want to know which one is changing the order. If I look, it's going to be the first one because this 3 plus 2 plus p is the same thing. Because if I were to replace this p with like a 1, it's going to get us the same answer, right? If we just flipped the numbers, it's going to get us the same answer. So that's commutative for changing the order. Okay. Inverse. Remember, inverse is the word that we talked about that means the opposite. So it's the opposite or the reciprocal. Remember, we talked about when we do keep, change, flip, how flip actually means we're multiplying by the reciprocal. Okay, so it's either the opposite or the reciprocal. Well, -3, the opposite of that would be a +3, and they did 0, so that doesn't make sense. That can't be inverse. This one, again, they're just, hopefully you see what property is being done here. That's not the inverse. If I'm looking, well, if I put 4/1, the reciprocal, or when you flip, is 1/4. So yes, this is the inverse property. Okay. Identity, remember, it keeps its identity. It stays the same. So that's either multiplying by 1 or adding by 0. And the one that's keeping its identity, -3, -3. That's my identity property. Okay, now we're going to go ahead and do the, what's the next one? Oh, distributive. Hopefully you see I kind of made the arrows on this one, right? Let's see why it's this one. I'm taking 7 and I'm multiplying it by everything that's on the inside. And I'm looking, and well, yeah, 7W minus 84. So distributive is that one right there. All right, backside, I want to circle all of the expressions. Remember, expressions means that it has no equal sign. It's like an incomplete sentence. I didn't give you the answer. I'm not telling you what the answer is. It's an expression. The product of a number and a is 16. So the product of a number and 8 is 16. That has an equal sign, so no thank you. This has an equal sign. Does 3 squared have an equal sign? Nope. So that is an expression. T divided by 8. Am I telling you what T divided by 8 equals? Nope. This is an expression. The product of a number and 8. So this is just the product of a number and 8. Am I telling you anything else? Nope. This is it. A number n, plus 1. Not telling you an answer. 2 plus 2 is 4. It has an equal sign, so that can't be it. A number minus 6 is 2. So a number minus 6 is 2. Well, it's telling me what the answer is, so it's just those 4. Okay. Which expression is not equivalent? And it's kind of funky looking here, but I'm going to rewrite it to 1/4 times x minus 12. So I want to know which one is not equivalent to that. Hopefully, you're kind of already thinking, well, I'm going to distribute this 1/4 to everything that's on the inside. So it's like I'm doing x times 1/4. Well, here, I'll write it like this. X 1/4 times x minus 1/4 times 12. Well, if I'm looking, I'm not necessarily seeing that answer. So let's break it down how we would if this is a fraction. Just like I said over here, and a fourth is the same thing as dividing by 4. So let's go ahead, and it looks like we need to rework this. So if 1/4 is the same thing as dividing by 4, well, x divided by 4 minus 12 divided by 4. And remember, when we're talking about algebra or anything like that, we really don't necessarily write 1x, but it's the same thing as just keeping an x. Well, this looks like this right here. So that, because I want to not, so that can be it. If I were to keep going, right, and looking, I'm going to ignore B for right now. I'm going to go to C. Is C dividing everything by 4? Hopefully you're saying yes, because it's still dividing everything by 4. So that is correct. It's still using the distributive property. Let's go to D. I hope you can tell me what D actually did. D actually solved it a little bit, simplified it a little bit further. What's 12 divided by 4? Hopefully you're telling me 3. And then I'm just going to bring that x over 4 down. Remember, because 1x and just x by itself is the same thing. Writing 1x is a little repetitive. We just write x. So D matches. Let's see why B is wrong. What did B forget to do? Hopefully you're thinking, oh, well, B forgot to divide it by 4 to match this up here. If you look, everything except D is dividing by 4, but D simplified it. So hopefully we saw that B was forgetting to distribute that 4 to 12. Which is not, another not question, not heavy today, which is not an example of prime factorization, and why. Well, remember I said prime numbers are numbers that can only be divisible by 1 and itself. So I'm just going to go through these and see that they're all prime. Well, 3 is prime, 5 is prime, 11 is prime. 5 is prime, and 7 is prime. 7 is prime, 3 is prime, 13 is prime. 2 is prime, 9 is not prime. So D is not an example of prime factorization because 9 is not a prime number. And remember I said that earlier, sometimes students like to think, oh, 9 is odd, it's prime. No, 9 can be divisible by 3, 9, and itself. It has another factor, so it cannot be prime. 9 is not a prime number. Okay. Next one. We kind of saw one like this in our expressions worksheet. Whoa. Let me do that. In our expression worksheet, hopefully, again, the alarm bells are ringing. Then I'm taking 43 and I'm distributing it to everything that's on the inside. So it looks like 43 times 152p minus 43 times 76. I'm looking. This one did the first distribution right, but it forgot to distribute to 76. This one, if I'm looking, let's see what it did. Oh, I think what it did is it did 43 minus 76. That's not what it's asking us to do, so no. This one is not even associating the right numbers together. P, the variable, was not with 76, so that can't even be the right answer. If we look, D is matching exactly what we did for the distributive property. All right, and last but not least, number 10. The model below represents the equation 4n plus 3 equals 2n plus 7. Which value of n makes the equation true? This is when we take our answer choices and we plug them into our answer. So 1, 1, 1, 1. Remember, I'm taking the 1 first. So 1 times 4 is 4 plus 1, 2, 3. So 4 plus 3 is 7. So in order for this to be the right answer, I want to get 7 over here. So 2, right? 1 times 2 is 2. 3, 4, 5, 6, 7, 8, 9. So 2 plus, 2 plus 1, 2, 3, 4, 5, 6, 7. 2 plus 7, well, that's 9. 1 can't be our answer. Let's go with 2, plugging in the 2. 2 times 4 is 8, so 8 plus 1, 2, 3. So that would mean 8 plus 3, 11. So in order for this to be my answer, I have to get 11 on the other side. So I have 2 times 2 is 4. 4 plus 7, well, it's 11. So this one might be my answer. Let me just check the other ones. So I have n equals 3. So again, 3, 3, 3, 3. 3 times 4 is 12. 12 plus 3 is 15. So in order for this to be right, I want to get 15 on the other side. 3 times 2 is 6, and 6 plus 7 is 13, so that is not correct. And then last but not least, it's 4. So again, a 4 is getting plugged in. And then that's 4 times 4 is 16. 16 plus 3 is 19. 4 times 2 is 8. And 8 plus 7 is 15. So that's not right. So B was our correct answer. Another way you could do this is also to just plug it in directly where the variable is. So if I were to do 4 times 2 plus 3 equals 2 times 2 plus 7. 4 times 2 is 8, right? And then we would do the 8 plus 3, that's 11. Excuse me. 2 times 2 is 4. 4 plus 7 is 11. So that's another way to check our answers. And again, remember the point of a review video is that you watch it as many times as you need to. Definitely review these properties, guys, because that's going to make our lives a lot easier when we're looking at questions like 9, 7, right? 9, 7, and even 10. It's going to help us really understand what kind of properties they're asking us to look at.